Good morning, all of you. My name is Miss Vinaya Pawar, MSc in Organic Chemistry, Assistant Professor, Department of Chemistry, Yeshwantrao Chaman, Institute of Science, Satara. Today I am going to Physical Chemistry, MCT P302 Electrochemistry, Unit 4 Fuel Cells and Corrosion. Content Fuel cells and corrosion. Significance of fuel cells: hydrogen oxygen fuel cells, hydrocarbon air fuel cells, natural gas and carbon monoxide air fuel cells. Second, B part corrosion. Concepts and importance, mechanism of corrosion and drawbacks. Firstly, what is fuel cell? Fuel cell is an electrochemical cell that converts the chemical energy of fuel, hydrogen and oxygen into electricity through a pair of redox reaction. Then diagrammatically, these are construction and working of fuel cells diagram. Firstly, these fuel cells part or branch is electrochemistry. Then definition of electrochemistry. Electrochemistry is the branch of physical chemistry that studies the relationship between electricity as a measurable and quantitative phenomenon and identifiable chemical charge with either electricity considered an outcome of a particular chemical change or vice versa. Electrochemistry discovered by English chemist John Daniel and Michael Faraday. Then electrochemistry basis of this principle: oxidation and reduction. The term redox stand for reduction oxidation. It refers to electrochemical process involving electron transfer to or from a molecule or ion changing its oxidation state. For example, sodium react with chlorine. Then sodium 1 electron donate to chlorine and also oxidize plus 1. Then chlorine accept 1 electron and it's oxidize to reduce 1 electron. The sign of the oxidation state, positive or negative, actually corresponds to the value of each ion. Electronic charge, the attraction of the differently charged sodium and chlorine ions, is the reason they form an ionic bond. Next part of electrochemistry, most important, electrochemical cell. An electrochemical cell is a device that produces an electric current from energy released by a spontaneous redox reaction. This can be caused from spontaneous electricity, for example, galvanic cell and voltaic cell. A galvanic cell whose electrodes are zinc and copper use zinc sulfate and copper sulfate is known as Daniell cell or half reaction of Daniell cell. Zinc electrode acts as a anode reaction zinc to convert zinc 2 plus 2 electron expelled. This reaction are oxidative reaction. Then copper electrode acts as a cathode. Cu 2 plus 2 electron gives Cu as it is solid. This reaction known as reduced reaction. Then cell diagrammatically represent zinc 2 plus oxidize, then cell Cu 2 plus and reducing Cu. Then topic main part, fuel cell. A fuel cell is an electrochemical cell that converts the chemical energy of fuel, often hydrogen, and oxidizing agent, often oxygen, into electricity through pair of redox reaction. The first fuel cell discovered William Gravey in 1838 to 39. Fuel cell is a galvanic cell. Then types of fuel cell. First, hydrogen oxygen fuel cell is discovered by Farnes and Thomas Bacon in 1932. Second type of fuel cell, alkaline fuel cell. This discovered by Thomas Bacon in 1960. He worked NASA to generate power of satellite and space capsule. Then application of fuel cells, mostly used to primary and backup power for commercial, industrial and residential buildings and areas, and in remote as insensible areas. And second most application, they are also used to power fuel cell vehicle, including forklift, automobile, buses, boats, motorcycles and submarines, etc. Then what is fuel cell? Another one. Fuel cell are electrochemical device that converts chemical energy from the reactant directly into electricity and heat. The device consists of an electrolyte layer in contact with a porous anode and cathode or either side. An illustration of a fuel cell with reactant, product, gaseous and the ion conduction flow direction through the cell is shown in figure. This figure proton exchange membrane fuel cell. Firstly, construction. First point, hydrogen gas and oxidant or oxygen flow field. Hydrogen fuel is channeled through field flow plates to the anode and one side of the fuel cell, while oxidant, oxygen or air, is channeled to the cathode on the other side of the cell. Second part, most important part, used as a catalyst. At the anode, a platinum catalyst causes the hydrogen to split into positive hydrogen ion, protons and negatively charged electrons. Then third part, most important, polymer electrolyte. This membrane allows only the positively charged ions to pass through it to the cathode. The negative charged electrons must travel along an external current to the cathode, creating an electrical current. And fourth most one, unused fuels and oxidant are expelled out. In standard fuel cell, gaseous fuels are fed continuously to the anode, negatively electron, while an oxidant, oxygen from the air, is fed continuously to the cathode. Positive electrode electrochemical reactions takes place at the electrodes to produce an electric current. Some of the advantages of fuel cell systems are. Then firstly, fuel cell. Fuel cell is a galvanic cell in which the chemical energy of fuel oxidant system is directly converted into electrical energy. Second point, in fuel cell, two electrodes and an electrolyte is present. Third, the fuel and oxidant are supplied to the electrodes of the cell continuously and separately. Third one, Sir William Gravey developed this cell in 1938 to 39. He used platinum electrode and hydrogen and oxygen. This diagram. These are platinum electrode and fuel use hydrogen gas and oxidant use oxygen, air or water. The electrodes are porous, providing a large surface area. Step first, chemical energy converted into mechanical energy. Step first, chemical energy converted into heat. Step second, heat is converted into mechanical energy. And step third, mechanical energy is converted to electrical energy. The extent to be which heat is converted into mechanical energy is limited. But in fuel cell, chemical energy is completely converted into electrical energy and 100% efficiency. Then fuel cell is represented as fuel, electrode, electrolyte and oxidant. Firstly, in fuel cell, fuels can be used liquid or gaseous form. Firstly, liquid form. Liquid fuels like methanol, ethanol, hydrazine, formaldehyde or etc. And gaseous fuels used, for example, fuels like hydrogen, alkane and carbon monoxide. And then oxidant are used like oxygen, air, hydrogen peroxide and nitric acid etc. are used in oxidant. For electrodes used as mostly as acts as a catalysis, platinum electrode, porous PVC electrode, nickel boride electrode, Renni nickel, Teflon coated with silver. Teflon is a polymeric nature. Inorganic polymer are coated with silver metal electrode are used. Fuel cell are classified on the basis of temperature. Fuel cell are also three classifications types on the basis of temperature. Firstly, low temperature cell means below 100 degrees Celsius. Third, medium temperature cell means 100 degrees Celsius to 250 degrees Celsius. And last one, high temperature cells above 500 degrees Celsius. Then lastly, biochemical cell are also used or fuel cells used. Also known, organic compounds are disintegrated by microorganisms in biochemical cells. Then this diagram are fuel cell. A single PEM fuel cell configuration. PEM means proton exchange membrane fuel cell. This diagram construction and working also same. Hydrogen acts as a fuel and then water, another chamber, acts as an oxidant in oxygen. Then as a catalysis, platinum electrode and electrolyte as a polymer compound, and then chemical energy converted into electrical energy. Then applications, a high operating efficiency that is not a function of system size. A highly capable design. Several types of potential fuel sources are available. Zero or near zero greenhouse emission. There are no moving part in the fuel cell stock which provides relief. Vibration free operation. There may be pumps or compressors in some fuel cells plant subsystem. Nearly instantaneous recharge capability when compared to battery. Then significance of fuel cell. Most important part, significance of fuel cell. First significance. Fuel cells can emulate pollution caused by burning fossil fuels. For example, petrol, diesel, kerosene, etc. For hydrogen fuel, fuel cell the only byproduct at point of use in water. In the hydrogen comes from the electrolysis of water driven by renewable energy. The using fuel cells eliminates greenhouse gases over the whole cycle. Fuel cells have a higher efficiency than diesel or gas agencies. Most fuel cells operate silently compared in internal combustion engines. They are therefore ideally for use within buildings such as hospitals. Fuel cells can eliminate pollution caused by burning fossil fuels. Fuel cells do not need conventional fuels such as oil or gas and can therefore reduce economy depends on oil producing countries, creating greater energy security for the user nations. For example, Saudi Arabia, Iran, Iraq. Since hydrogen can be produced anywhere where there is water and a source of power, generation of fuel can be distributed and it does not have to grid depart. The use of stationary fuel cells to generate power at the point of use allow for decentralized power grid that is potentially more stable. Low temperature fuel cells, for example PEMFC, means proton exchange membrane fuel cell, and DMFC means direct methanol fuel cell, have low heat transmission, which makes them ideal for military applications or defense applications. Next, higher temperature fuel cell produce high grade process heat along with electricity and are well to cogeneration applications such as combined heat and power for residential use. Operating times are much longer than with batteries. Since doubling the operating time needs only doubling the amount of fuel and not the doubling of the capacity of the unit itself. Unlike batteries, fuel cells have no memory effect when they are getting refueled. The maintenance of fuel cell is simple since there are few moving parts in the system, mainly part. And next point are comparison of a fuel cells and a battery. Then battery. Some of the unique characteristics of the battery includes: first, it is an energy storage device. Second, the maximum amount of available energy is based on the amount of chemical reactants stored in the battery itself. Third, a battery has the fuel and oxidant reactants built into itself on board store, in addition to being an energy conversion device. In secondary battery, recharging regenerates the reactants. This involves putting energy into the battery from an external source. This diagram, lithium ion metal battery or fuel cell. The lifetime of primary battery is limited to the following. The battery stops producing electricity when the chemical reactant stored in the battery runs out. Then, when a battery is not beginning use, a very slow electrochemical reaction takes place that limits the lifetime of battery. The battery life is depend on the lifetime of the electrode. In comparison, then some examples of batteries. First, alkaline battery to use automotive battery. Second, aluminum battery, use backup battery. Bunsen cell, bio battery. Dry cell, electric vehicle battery. Galvanic cell, flow battery. Lithium ion battery, nickel cadmium battery, nickel metal hydride battery, lead acid battery. Lead acid battery also used in mobile or electrical vehicles. Lithium-ion battery used in especially mobile batteries and smart devices, and lead-acid battery used in vehicles. In comparison, a fuel cell is an energy conversion device where the reactants are supplied. The fuels are stored outside the fuel cell. A fuel cell can supply electrical energy as long as fuel and oxidant are supplied. Also, no leakage occurs in fuel cell and no corrosion of cell components occurs when this system is not in use. Some of the limitations common to all fuel cell system. Some three are limitations: cost effective, mass produced pure hydrogen storage and delivery technology. Second, fuel reformation technology may need to be considered if pure fuel is not used. And last one, fuel cell performance may gradually decrease over time due to catalyst degradation and electrolyte poisoning if pure fuels is not used. Thank you.